All right. Hello, world, and welcome back. Today we are going to try to knock out the next step for collision detection. We have tile-based movement, but you can still walk through everything. So what we need to do today is add some checks against the collision layer and against the NPC array, basically. Oh, we need to create an NPC array. See, we have one NPC, we have our collision layer, but we're not doing anything to the collision layer yet, so let's get to that. If we go over to our main source file, we're not moving, we're going to say that the player can move. Now what we need to do is basically, we need to modify move by, check to see if it's possible to move before actually changing the target position. So add a, before we get too far into this, add a little sanity check here. Move by, if self dot is moving, then return. If we're already moving, don't even want to try. And yeah, see if that broke anything. No? Okay. So all of our collision data is in the basically the collision level. We need to figure out a way to see if there's anything defined in the collision, basically the collision layer of the level or the given position. So what we're going to need to do, we're going to need to take the player's X and Y position, convert that into tile coordinates, and then take that back to the map to see if there's anything there. Um, so we're going to do a couple things. First, we're going to work on the translation. Transformation of coordinates from pixels back to tile coordinates. Let's say if should move camera means that the player was moving and the player is now not moving, let's print the player's current position. That will give us a start. Actually, want to get the X and Y out because we're going to be having all kinds of fun with those X and Y values. Okay, let's see what that looks like. That'll be our starting point. I really don't like the orange color. I need to fix this right quick. This was a problem in the last video too. X.color equals color dot red. You can set the colors with HTML colors, basically. HTML color codes. Just try and remember if our red comes first or if alpha comes first. Let's try this. That might make it... That's either going to make the background color red or the background color translucent. So, let's check it out. See, that's so much easier to read. I'm so glad I did that. Now, first of all, we need to divide the X and Y values by the tile size in pixels. See, it's still red there. I don't like it. I'm going to restore everything back to the way it was. I imagine we're going to get a whole bunch of these, so let's take all that, put it in our init file. And then this goes in the cleanup. Okay. I'm gonna leave that, try to leave that alone now. The tile size and pixels. We already have a constant for that. Let's use it down here in our transformation. Where did I put that? All right, let's see what that looks like. That actually looks awful. Wow, the output is fine. But I don't like that printing something is dumping all that junk on my display background. Having that red color is probably enough. Hold on, let's just from the top. Okay, so you can read it well enough, and you can see everything's off by 0.5. So let's take off the 0.5. You can see that the y values are going to 0 as we go down, and then they're going negative, which I did not really expect. We're going to try this a different way. So if we go into math, convert tiled pixel coordinates into mini macro coordinates. Returns a point. Let's run this in reverse. And I actually mashed together so much math that it actually makes it harder to reverse. Gotta think about it for a minute. Let's look at these side by side. Right now we're dividing by tile size in pixels, minus 0.5. One of the things we're doing here, we have reference to the tile display center X and Y. Those are in pixels. Okay, so we were gating that and adding it. So let's try adding those back to the X and Y coordinates and see if we can get rid of that negative. That should have... Oh. And why that didn't have any effect is because doing a plus equals followed by reassignment. So the original thing was overwritten. Okay, try that again. Okay, so that's looking good. So 0, 0. X is 0 at the far left. It's 31 at the far right, which is correct. Now we just need to invert the y to put the 31 at the very top. No, put the 31 at the bottom, put the 0 at the top. So it matches the format of the tiled file. Okay. Now, tiled level height. Size is 32. Because width and height are both going to be 32. It's going to go in our constants file. Constants. Invert the y. And one more check to make sure our numbers are right. Now what's funny is that it now says y equals 1 for the top. So what's the bottom? It's 32. It's off by 1. We're just going to subtract 1. One more check. And now we should have 31, 31 in the bottom right. Okay, so that part's good. We now know where we are. I want to make that part of our entity. Making part of the entity means that we can easily apply the same math to the NPCs. For the current position and the target position. And there we go. I don't know if we need, yeah, we do need the target tiles. We probably need that more than we need the current tile. Well, I need to know the current tile for colliding with other characters. So we'll keep that one. Okay, so now we know where we're at. We need to know if it's blocked. So we need to get that collision there. So we go back to the library. Let's look at the layer, see how I get the data out. We have an array of tile IDs. So parse data is how that's populated. And it looks like it's creating a two-dimensional array. So, oh, I didn't catch if it's XY or YX. The length should be rows. So I think it's going to be row column for the indices. Row is the Y, column is the X. Let's see what that gives us. What I hope it gives us is that any place that is marked as blocked in the tile map, like all the walls and trees, should print a 1 or blocked. Let's find out. Key not found. Well, I could just do that instead. Okay, so collision layer dot data. Let's try that again. And it's, giving us nothing. I was hoping for something. Okay, collision data, YX. Let's see the raw file again. Assets, maps, town version 3. The object layer. Decoration. Base. And there is the collision layer. So basically, if it's 0, you can walk there. Let's inspect data before we go on. Because I just want to be sure about what's in there. It's not quite what I expected at all. Oh, let's do an inspection of each layer. Hold on. It's still not scrolling, but basically, I'm seeing a bunch of zeros in there, which is fine. I guess this isn't the best tool for inspecting a large two-dimensional array. It's blocked if this doesn't equal 0. Let's try that again. Blocked is 1. And it just keeps being 1. Like, everywhere. The question is that collision layer actually getting populated the way I expected? We're at T level. Try again. We're gonna get the layer. See data 0, 0. Can't index into this type. Interesting. Okay, it's not a two-dimensional array. That is probably the entire problem. Yeah, okay. So I see what's going on. It's just one-dimensional array where you have this width and height defined, and it's just calculating the x and y as it runs along. So you can see in the render function, there's no two-dimensional loop going through the array. It's just going from beginning to end with the x and the y values coming from there. Being calculated based off of the current tile and the width of the map, which does make sense. We just need to reverse it here. Basically, we need to calculate the tile index. Tile index is y times collision layer dot width plus x. Let's see how that does. And that was wrong. What did I do in my tile layer? Looks like yeah, okay. Typo. It's okay. Blocked is 0. Blocked is always 0. Okay. Am I crazy? Hmm. Well, there was a 43 there for just a second. Um. Oh, because we're looking at the current position instead of the target, which we were just talking about. We had all those nice functions and didn't even use them. This is at least part of the problem. It might not be the entire problem. Index must be numeric. Didn't expect that. Am I returning everything? No, I am not. Return X. Return Y. You have to actually return the value after you calculate it, or it doesn't count. I'm still getting a 0 like everywhere. Almost everywhere. That's a 43. Is it supposed to be a 43? Yeah. Okay. Now we play the guessing game of what did I miss? It's off, but I'm not sure why. That's interesting. It's almost like the Y got inverted again. Why would it do that? Let's this. Okay. And it looks like that's exactly what happened. See if we can figure out why right quick. It's this. Because while it's loading, it's inverting the Y for us. Which makes sense. Yeah. Since mini macro renders with 0, 0 in the bottom left, we need to invert the tile rows. So yeah, that makes sense. And I think I'm going to just solve it like this. Re-invert it again. It makes more sense in my head. Run one more test. And blocked at 0. We're off by 1. That's blocked, blocked, open, open, blocked, open, blocked. Okay, that appears to be giving us the right value now. So basically, ultimately, we need to shove this data into our level so we can ask the level if it's blocked at that position. I think the way I'm going to do this is by subclassing type because it's a detail of the map that's really specific to how this game is written. So if we look down here, okay, so first, having this refactored out could help us later. And we will hit the collision layer. This bit here is just about not having magic strings. I don't like magic strings. And at least make sure we don't repeat them. So, check to see if it's blocked. Um, Getting the tile index probably could go back up to the tiled layer. Okay. We don't need that in the level. Ask the layer for the tile index, and then check to see if it's blocked, and then return that. Let's modify this down here to use the new function. Test is blocked is not found. Oh, okay. What did I forget? Let's see what exactly the load function is doing. Going back to the initialization, it's importing the tiled file, standard locals. So let's go into library, tiled, load. It's creating the tiled level, not our special RPG light tiled level, which of course will not work. Let me think how I want to do this. I think I know what I want to do. I just basically loading a tiled level should belong to the constructor of the tiled level. And I think I'm going to move this. So that inheritance will work correctly once more. Need to remember to create a new object before running load now. Okay. So this file is basically not needed. I'm gonna leave it in place for the moment. And loading, that should be how you load it. We're inheriting from tiled level, not tiled. Okay, let's try that again. Tiled level is unknown in this context. Oh, really? Let's make it known. Sometime after I'm done recording, I'm probably going to redo how these imports are done because I just don't like doing it that way. It feels ugly. Version is unknown. Tiled level version 971. Why is it even checking the version? Hmm. I'm not sure this property is needed. Let's pull it from that version. That's just not needed at all. It looks like it's just set there to just to give it something. I'm going to move that in case it matters. Okay. We're able to ask the level if a space is blocked. So that's great. Trick, we need to actually not allow movement if it's blocked. So, I think what I'm going to do is pass the level to the entity that's trying to move. Bye. So I guess the big question is, should it be the first parameter or the last one? Let's make it the first parameter. And bigger question is if I should wrap that entire thing with another class that will contain the level in the sprite array. Oh, not. I'm not. We don't need keep adding layers to this. Okay, so back to our entity. Update, move to, move by. Let's go ahead and pre-calculate the target position. Next level, if that position is blocked, return false. False means there's a hit. Should be all we need to do to get collision with the world going. Ooh, out of range. What do you mean out of range? 911. Oh, we're looking at the target position. We need the tile position. Hmm. Problem is we don't have the tile position yet. We just have that pixel coordinate we're aiming for. This is not ideal, but I'm going to do it anyway. I am probably going to be refactoring this offline. But I'll let y'all know how it goes. Alright, so getting the tile position to check on the level. So we can still move around. And we're blocked. We cannot move through the wall anymore. Oh yay, that makes me so happy. But, you know, we can still do that. So let's fix that next. Don't need to be looking at this anymore. What we're going to do with entities layer, put our guys in it, guys or girls. And then we need to go back to our movement function. basically, level is blocked. No, we don't need to modify anything. We need to modify the level. The level is blocked if that tile index is blocked or entity in self.entities. The target tile x equals x, and the target tile y equals y. So if that target tile has already been claimed by another entity, return true, meaning the tile is blocked. Otherwise, return false because it is not blocked. Let's see. Was it that simple? After all that, here comes the test. And there we go. We cannot walk through that guy. The way is blocked. That makes me happy. Let's celebrate by adding another NPC to the board. What's that index 27? Let's find out. NPC 0 is 26, NPC 1 is 27, player is 41. And there we go. Now we have two NPCs, neither of whom we can walk on. And that does it for today's episode. I think next time we're going to be working on the user interface a little bit. I don't really like just dumping text to the screen. We can find better ways to do this, and we need to start getting some kind of heads-up display going. And then maybe we can start talking to these NPCs. So, I think that will do it for today. And see you next time.